Hi guys, welcome to the new episode of MathSci. My name is Sujat and we are going to discuss about electrochemical consideration. Electrochemical consideration. For metallic materials, the corrosion process is normally electrochemical. That is a chemical reaction in which there is a transfer of electrons from one chemical species to another. In short, electrochemical consideration is a redox reaction, since corrosion is an application of a redox reaction. But the million-dollar question is, what is a redox reaction? A redox reaction is comprised of two half reactions, a reduction half reaction and an oxidation half reaction. Note that these two types of reaction always occur together. Now, let's differentiate the two. In reduction reaction, the mnemonic that we need to remember is GAROA, which means gain of electron is reduction, that is also called as oxidizing agent. On the other hand, the mnemonic device for oxidation reaction is LIARA, which means loss of electron is oxidation, that is also called as reducing agent. Moreover, we should also take note of the mnemonic ANOX red cat, which means oxidation happens in the anode site while reduction occurs at the cathode. Let's try to test our knowledge with a simple problem. Determine which element is oxidized and which element is reduced in the reaction between zinc and two molecules of hydrogen forming zinc with a charge of +2 and dihydrogen. So, here is the solution. Zinc is the one being oxidized since from a neutral charge, its oxidation number became +2 in the product side, meaning it lost its 2 electrons. Furthermore, hydrogen is the one that is being reduced because in the reactant side, its oxidation number is +1, but in the product side it became 0, which means that it accepts the electrons that the zinc lost. Now, let's move on to the next topic, which is about the electromotive force or EMF. EMF is the potential difference between the anode and the cathode in a cell. It is also called a cell potential, which is denoted by the symbol uppercase letter E with a subscript cell. Consequently, the standard cell potential is equal to the cell potential of the cathode minus the cell potential of the anode. Also, in solving cell potentials, we need to use the table for standard reduction potentials. This table shows the voltage recorded in the reduction half reaction of an electrode. For better understanding, let's try this problem in solving the standard cell potential. In this problem, it is already defined that zinc is the anode, which is the one being oxidized or the one that loses electrons, and copper is the cathode, which is the one that gains electrons. Based on the table for standard reduction potential, the voltage of zinc or the anode is negative 0.76, and the voltage of copper, which is the cathode, is positive 0.34. Now, all we need to do is to get the difference between the voltage of the cathode and the anode, which is 0.34 volts minus negative 0.76 volts equals to positive 1.10 volts, meaning that this reaction happens spontaneously since the resulting difference is positive. As an additional information, the greater the difference between the voltage of the cathode and the anode, the greater the voltage of the cell.